universe is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light. And I've heard others call from light years away. And they're real, and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space, fields and forms, path and voids. It all sings with one voice. It's home. Boundaries set, foundations laid. Sound was heard, matter made. Solar systems from afar. Names and numbers for the stars. And I've heard others call from light years away. And they're real, and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space. It's the Lord's.
Hello, everybody, and welcome to SkyTour Livestream again for this wonderful evening. It's so good to see you guys with us. And as always, I have with us Daryl Mason. Hello, Daryl. How are you?
Hello, Mark. I'm good. You? Hello, everybody.
Excellent. Doing just fine. We've got a lot going on. I figured we'd just hang out for an hour or two to check out a few more items. And maybe do some more deep sky shots of things that we missed yesterday. I want to say hello to Tim F. I want to say hello to Calibos. Hey, how you doing, man? Michael Galea, what's going on? And James Hyatt's with us 2 nights in a row. That's right. Yeah. So we're going to give our best shot here tonight. This right here is Measure 22 that we're looking at. It's a globular cluster in Sagittarius. One of Daryl's favorite clusters, if I don't miss my guess, right, Daryl?
Oh, yeah.
Yeah.
Long-time favorite.
Yeah. This is pretty. So, yeah, I'm just getting a few more things straightened out. I brought you guys in a little early. But that song at the beginning, that is the complete song, The Universe is Calling You by Rebecca Renfro Borneman. And she wrote the song, and it's our theme song for SkyTour Livestream. And she's a good friend and a marvelous artist. She does everything, almost everything on that song. So I got her permission today to use it. And it's tied to an older video, so we're going to redo that video with all of our latest imagery. So it's going to look much better than the images you saw there, because as Daryl was pointing out before we went live, or Alice was playing, he's saying, you need to update that imagery because it doesn't hold a candle to what happens now. That's right. We are doing so much better, you know?
Oh, yeah.
Yeah. And for the record, I did focus right now, so we are critically focused. I'm going to actually take, again, this is measure 22. I'm going to do a 15-second shot. Why? Because I just want to see, what it looks like right now, because the sky is not quite dark out there, but we're working on it, and we're going to see what we get here. So we'll just go into our stack here. You'll probably see a red fringe around the edges. That's my guess, because we still have the remnants of sunset out there. So we're going to have a little bit of red in here. A very sensitive camera. But let's see if I'm right.
Astronomical twilight was 4 minutes ago for Arizona, so
Okay.
that is pretty red.
Yeah. Let me go and do a little processing. It seems okay. That's good.
Nice.
Yeah, that's measure 22, guys. It looks really pretty. And what we can do is we can jump into the core by dragging this down and kind of dig right in, and now you can see right into the core. Isn't that cool? That's really cool. Very cool. I like that. That's really neat. Neato. I like it a lot. Yes, yes, indeed.
Yeah.
All right. Okay.
This is just above the top left corner of the teapot, Sagittarius.
Yeah, let's
It'll
bring up
pull it away pretty quick.
Stellarium and show people where we are. So that's where we are. Caus Borealis is that star there, but measure
That's
22 is up
Top
here.
of the lid of the teapot.
Yeah. And there is the Great Sagittarius Cluster, and if we zoom out, you can see the top of the lid of the teapot there. And there's actually several globular clusters in this region. You have measure 28 over here. You have NGC 6638 here. You've got the tadpole cluster there. And then these little green diamonds are planetary nebulae. Little tiny planetary nebulae. They're not very large, but they're cute. But we don't have the ability to zoom in to those, even with this new camera. We would need the next telescope to do that, and that's what we're going to have for that. So it'll be great. All right. So, let's see. We've got 8 images stacked here in our 15-second shot, and we'll just do a few more. And I'll write in here that this is M22 and then GC for Globular Cluster. And if you want to know where to go, you go here to skytourlive.org right there, and that will give you access to our server where you can see these pictures literally within 30 seconds of being taken after I save them. I want to say hi to Alice Pooper. I want to say hi to Rocket City Astro. What's going on? Sam S. is with us. And Kathy Prendisek is with us. How are you? Nice to see you in here. And Jane Murdoch is with us. Hey, Jane. What's happening? I want to thank you for helping out around here with all the yard work you were doing. That was pretty nice of you to do that. Jane likes to cut down trees and things, so you got to sort of keep her away from the trees because she'll just cut them down. She's crazy. She'll just cut them down. No, I want that tree. That's my car. No, the chainsaw doesn't work on the car. At least I didn't think it would, but as she proved me wrong, it certainly does. So anyway, I'm kidding, of course. So yeah, Measure 22 is looking really pretty here. And let's bring back what it thinks the setting should be, and you'll see that it's going to really push it. When these two lines are close together, we're really pushing and squeezing the processing out there. Oh, look, we had a satellite come through right here. That little fine line.
But that's what M22 is supposed to look like.
Yeah.
I've said before, if it was farther north, it would rival Messier 13 and Hercules.
Oh, yes. I think that you're right. Absolutely. Okay, so this is 15. We'll stop here, and we'll save it. Tonight, the images are going to be even more crisp because we've taken the gain down a little bit. If you look over here, you'll see we have the exposure, and then we have the gain. And the gain is how sensitive the chip is. And the more sensitive the chip is, the more we're going to find that the noise will be cut into our data, and we don't want noise. So we'll get rid of the noise by dropping the gain down a little bit. It'll be a little better anyway. So if we were to zoom in on this, let's see what that shows us now. Yeah, we can see individual stars in there quite nicely. Look at that, Daryl. That's a beautiful globular cluster, isn't it?
Just a sec here.
That's
yes,
really,
it is. That's beautiful.
It is. Wow. Very nice. Okay, so we save, and then we'll save it exactly as seen. And what I'm doing is I'm now saving our files. And where do they go? They leave the observatory up there that you see right here. Okay, and behind me right there. They leave the observatory 2,600 miles from here and go all the way up to the cloud via satellite and make their way back to our server, where they're dropped onto the server. As we speak, this image is being dropped on the server right now. So you'll be able to see that in just about 30 seconds. If you go here to skytourlive.org again and check it out.
Yeah,
So,
I just posted the link to the server.
Oh, thank you very much.
Yeah. Rocket City says you shouldn't change the gain ever. It should always be set to unity gain specified by the manufacturer.
I've seen that argument, but I use higher gain, and by unity gain, do you mean zero gain? I prefer to have the ability to see objects quick. All right, let's do this. I've heard that term, unity gain, and I wasn't sure what people mean by unity gain. Okay, set to 105. Well, you're allowed to change the gain on the cameras. That's the whole point. And so I do that. And there's never been an issue. He says he runs his at 105, the gain of 105. Oh, I see. The most gain without creating noise. Yes, I get you. Each camera, though, has a different setting for that. This camera here is probably one of ZWO's most sensitive cameras. It's the 183 MC Pro. I would definitely try a night at what the gain would be optimally, but most likely people aren't going to have a good time watching it because they won't see all the details in the nebula, because I like to do 20 and 30 second shots to keep people interested. So I have to pump the gain up in order to bring in that data, and I can remove all the noise. If you've seen any of our high-end processing, I remove all the noise from the shots. So any noise that's in there is removed, and you just have nothing but smooth nebulae with all the kinks and twists and all the details retained, but the noise is gone. So it's pretty cool.
I didn't mean to start an argument.
No, you didn't. You didn't. And you see, the 533 is a camera that I went back and forth with. But guess what? For this focal length, the 183 MC Pro is the best arc second per pixel camera that I could get for this focal length and this setup there, this optical setup. Keep in mind, this telescope is the only one on planet Earth that has an f2 focal ratio from Meade. It's a Meade LX600 system, 10-inch. And so it's the only one that's been converted to f2 on the entire planet. I know that for a fact because the people that did the conversion have never done this before. We were a prototype. So, and the 533 loses amplifier noise. You're correct about that. And our amplifier noise shows up over here on the left side for us. And so that actually disappears, as Rocket City says.
I'm going to change the subject.
Yeah, good.
Look at M22 there, and am I hallucinating, or does it look like there is a dagger stuck into the top of the globular cluster?
Right here?
Yeah, you see that?
Here's the cross. Yeah, here's the hilt.
Yeah.
And there's the thing, and it's being stuck right in there. That's cute. Are you hallucinating? Am I hallucinating? Well, yeah, you're hallucinating about it being a dagger, yes. But you're right.
I think that's cool.
Yeah, it is neat. See, now you got
like I said before, every globular cluster kind of has its own character and marks and details and stuff on it. And
yeah.
I guess we found M22s.
That's correct. Look at that. That's really pretty. Rocket City, one of the things I wanted to mention to you, too, is that 200 gain might be what we would call a unity gain for this camera. I don't know. I've taken pictures at 0, 50, 100, 150, 200, all the way up to 450 with this camera, just doing comparisons. And it seems like the sweet spot is at 200. So I've just noticed that. But keep in mind also that you've got to bring the temperature to the right temperature. So I have to wait till it goes down. Now my target temperature is minus 20 Celsius, and it's at minus 16 right now. And that's because the temperature out there is 24.38 Celsius in the building. So it's still pretty warm in there, and it has to cool down some.
It's supposed to cool down there tonight.
Yeah.
And as it cools down everywhere.
And as it cools down, we will need to refocus. I'm not using temperature compensation, this little button over here, because it doesn't work as well as I would have hoped it worked. I got a nice equation that I figured out, and the equation's relatively accurate, but I don't want focus to be changed in the middle of a image process that we're taking, like a bunch of images. Okay. So this is good. I saved the last one, and we're going to get out of it now. Okay, I'll do one more. I'll save it just for heck of it.
Yeah, it's a nice picture.
It is. It's worth saving. Okay, save exactly as seen. Okay, now I can get out of it, and we'll check out what it looks like with a 1 second exposure. And it's right here with our night vision mode. Okay, so we'll back out a little bit. You guys may notice that we don't seem to have as many delays anymore. That's because I made some changes to the program that does the remote access to the system. And now we can't fight whether if a Starlink satellite isn't available. But we had other induced delays that were caused by the connection software, and that's been changed, so now we don't have that problem. What shall we look at now? Actually, at 200 gain, we should look at the Eagle now, because we did it at 300 the other night. So let's do it at the lower gain and see if we can pick out the spires on the top of the main pillar. We could see them last time, but they were kind of hard. $120 is unity gain for my particular camera. Yeah, that seems about right. Keep in mind, the only difference in what I do is that I have an audience of people watching from all over the world, so I've got to be conscious of the fact that they're going to be interested, and to stay interested, I actually have to cater to that. So I do have to increase the gain sometimes. And I have this software, this software that I'm using can put in filters to reduce noise as we take the imagery, and then we remove the noise further when we do the processing later. Okay, so we'll start here. You can see the pillars already. It's really pretty. And once, okay, we're zeroed out, and now we're guiding. These numbers represent the fractional movements of the telescope. If they get above 2 or 3, that means there's wind. So when there's 0 point this or that, that's excellent, and we'll have perfect exposures. So I'm going to do a 35-second shot of this, and then we'll build a stack. Hey, Genghis. There we go. Jane says, "Good catch, Daryl." On the dagger.
I can't be the first person who's ever seen that.
You're the first person that's ever told me. You know, you got the propeller in measure 13, the dagger in measure 22. Man, you're just full of stuff. Okay, I'm gonna go into the stack now. I forgot to do the stack, but that's coming out good. So there's measure 22 with all this additional processing over there on the right. So we're gonna get rid of that, and then we'll clear this because we've already got it saved up to our location. And then I'm gonna put up here, we're gonna put the Eagle Nebula, measure 16. Eagle. That's that eagle. Eagle. There we go. Oh, look at that. Really pretty. Oh, look at that's really pretty there. Look at it. It's really crisp.
Uh-huh.
Let's see if we can pull in on this. Oh, yeah. Look at that. The fairy.
Yeah, fairies looks a little crisper than last time, too.
Yeah. Wow. We can already see the little horns on the top of the main pillar here. This is really crisp and precise. There's a connecting piece here. Ah, satellite. Shoom. That'll go away over time. Keep in mind what we're doing. That is, we are stacking images. We're taking a picture, taking a second one, aligning it with the first, and just adding their data together so that dark things become more pronounced and visible against the background of space, and light things become more crisp and clear without noise. This guy right here, look at that globule right there. That globule is really pretty. Holy cow.
Looks like it has a red top on it.
Yeah, I mean, look at it. This thing right here, it's like it's got a really pretty look to it. It's, you know, and that's an area of dust and hydrogen gas that's actually contracting under its own gravitational influence, its own gravitational contraction. And if you notice, it's kind of round. Look, another Starlink satellite went through. Notice this one's fading. And it's only on one frame. So as we keep adding frame after frame after frame here, those get subdued more and more and more. James, I'm glad you like the images. This is the Pillars of Creation. The image that Hubble took this pictures of these guys. Okay. And this is just looking so sweet. It is really a really sweet image. Outrageous. Hello, Paul Atreides. How you doing? Yeah, Paul says, and so did a couple other folks. Welcome to Pareidolia here when you're looking at a dagger. Trying to make order out of chaos. I'm very familiar with that because I got people that in my UFO world who talk about the fact that they're seeing certain things in the sky, and they say it can't possibly be pareidolia, when in fact that's all it can be. So I have my share of people that see pareidolic things too.
Oh, sure. It's human nature.
Yeah.
I mean, it goes back to animal nature, I suppose. Where it's a defense mechanism. You're looking for patterns and recognizable objects like, leopards hiding in the grass or tigers, stuff like that.
Yep.
And that's what animals do. And
Mm-hmm.
we see things that look like other things that aren't really there.
Yeah. Francis Palmer asked, are these the real colors? Yes, Francis. What's interesting about these colors is that you're looking at the color of hydrogen gas when it's ionized. Now, what does that mean? It means that the electrons are bounced off the atom, and when they come back in to the atom and recombine, even if only momentarily, as they fall back into the atom, they give off a characteristic light color. They give back the energy that they stole to leave the atom, and that give back is in the form of light. And for the hydrogen atom, the predominant color that the electron causes itself to emit is red. We call it hydrogen alpha, H2, Roman numeral 2, just plain H alpha. And so when we look at something like this, what we see is the result of a nebula that is lit by hot stars that have ultraviolet energy that the electrons in the hydrogen atoms grab and bounce off the atom for a period of time, then come back, and as they come back, that's when they do that emission of light. Oxygen does the same thing, and when oxygen does it, we see a green glow. All right, so that's pretty cool. This dark nebula does something completely different. In a region of space where there might be a lot of dark dust, the stars nearby may actually just try to illuminate the dust with their starlight, but the dust actually absorbs and scatters only the blue light coming in from the red, orange, yellow, green, blue, indigo, and violet spectrum. And when it does that, we see a blue glow, and that blue glow has come to be called reflection nebula, but it's created through something called scattering. In fact, in particular, a scattering process called Rayleigh scattering. This is really beautiful. I'm going to add an enhancement here, guys. I'm going to drop in a mask. So watch the pillars. Let's see if they get sharper. Oh boy, look at that. They just jumped in sharpness. Look at that. That's really pretty. Holy cow. I'm glad we did this tonight. I wasn't sure I wanted to do it. I'm going to drop this down just to give you a little more contrasty look. There, look at that. Now let's zoom in. Okay. This is about our limit right there. And you can see the little devil horn sticking off this top pillar. Let's see where it wants to go with processing. It might shock you here. Yeah, that's a little too much. Very cool. So that's about right, just like that.
Very really stands out now.
Yeah. Now, if we want to, we can show you what it would look like if we took a black and white picture. And for years, all we ever did was take black and white photos of the night sky. And now we take color pictures. And that's a little too much. Going to drop it back down here. So this is really nice. I'm really happy with that. That's pretty.
Mm-hmm.
Very cool. Yeah, now if we zoom over here a little bit, this is what's called the fairy. It's another feature within this nebula. Really, just a beautiful region. We can actually try to draw some more detail out of it. Maybe try to go this way a little, darken up things. It kind of shows this central core of black dust. Now see, this dust is buried inside a glowing hydrogen ionization cloud, okay? Then some of it is outside and free of the hydrogen, so you see it like this. It's poking through this sheath of hydrogen right here. And keep in mind, this is light years in length, okay? We're not talking about, small distances here. We're talking about extremely massive clouds. Let's go look at the globule. Oh, the globule is looking stunning here. And look, there's a smaller one right here, Daryl. Look at that.
Yes.
Wow, this is really pretty. These are standing up to this camera is standing up to the test. I can tell you that. It's really.
So is that globule? Is that a Bach globule? Is that a Herbig-Haro object?
It could be a Herbig-Haro once the star, if there's a star forming in there, begins to emit polar jets, off the north and south poles. Right now, it's just a condensing globule.
Okay.
Yeah, and this one here is the same. We don't know if there's anything inside there yet, but I've seen photos of, I think, this globule, not this one, and it shows that it's condensing under its own mass gravitationally. So it's going to get more and more compact, and if enough mass in the interstellar medium, what we call the ISM, if enough mass from the ISM collects in there, it might get hot enough to actually create a stellar body in there. And then to be a protostar, then protostars are not fusing anything yet. They haven't started the fusion process. It hasn't winked on, so to speak. But it still goes. Look, I'm just stunned here. This is gorgeous. You know what? I'm wasting some time here. I'm going to do this. I'm going to drop that down, and I'm going to just take us full screen here, get rid of the telescope for now. That's where we want to be, guys. We want to see this. Look at that.
I wonder, the one globule you pointed out, it's like almost straight down below the bright stars, which I assume are lighting up the nebula. It's dark, but it has the top edge of it is lit. It's
Yes.
red.
Yeah.
I wonder if you could actually compare that to the one that's just to the lower left, immediately lower left of the eagle. Looks like an egg behind the eagle. It's all red.
Are you talking about this one?
Yes. I mean, are they similar, but we're seeing the one dark because it's closer to us, and we're seeing the back side of it, with just the top part of it lit?
Hard to say, but I would say that what you're looking at here, and this right-hand one, we're actually looking at a dust mass that also has hydrogen in there too, and the hydrogen is ionized and it's a hot region in there. and it is ionized. However, I think that it's also dense enough that the ionization is thwarted. The glow of the ionization is overwhelmed by the dark dust. And for this one, perhaps it might be farther into the cloud as you're talking about. And maybe these stars are here and that thing is back here, so we're seeing mostly a lit frontal face of it. I don't know.
Right.
Yeah, the 3D nature of this cloud would be spectacular to understand. By the way, remember that satellite trail? Notice it's gone? Yeah, this one is on its way out too. Look at this. Wow. We're actually catching a lot of really interesting astronomical phenomena, guys. Calabo says, I'm a month away from returning to work at SpaceX and an effort to help Mark and Daryl. Yeah, you know what? I gotta give you kudos. I met Calabos actually out at Contact in the Desert, and his fiance Tiff, and I'm really proud of the work he's doing. So he's quite a guy. All right, he's a good person to know. So everybody, show your love to Calabos out there, because he's really very selfless about this, and he just wants to further astronomical education. There's many of you are like that as well, but he's trying to start some programs to do it, and I'm really impressed.
He says he's about to make us an offer. Maybe we'll get free stuff.
Well, you know what? I've never asked anybody for free stuff, but if it helps keep SkyTour moving forward and going into the future, then that's great. Rocket City says, are you doing the solar eclipse coming up? I can't. I'm in Connecticut, and it's not going to be here. Daryl will see a partial where he is in Colorado, and I will not see it at all. And folks down in Arizona will notice a big flaming ring in the sky, and of course they have to go outside and beat pots and pans to make it go away. Yeah. Very cool.
If you had a solar filter on the scope in Arizona, you could certainly see a partial. Probably as much or more than I'll see in Colorado.
Yeah, I would. I actually made a system to flip something down into the optics and pull it back up. The trouble is, I didn't get a chance to install it. It's actually out there in the building. And I actually built it with something called Berkey system. Berkey system is like Tinker Toys for adults, and I hooked it up to a servo motor, and I actually, for SkyTour East, I actually used it to close the telescope. It was a lid opener and closer. Well, that could also double as a solar filter addition, but that's something that I did not do, so it's not ready for that yet. That's coming though. I'm not gonna, I'm not going to shirk my responsibility on that. We got to do that, right? At some point. The goal is to have a solar telescope as well, so we could mount that on the system and get that to view the sun. Now, the way we would do it is we would set it up so that it was off-center from the main scope. So the main scope doesn't have to be closed. The main scope won't see the sun, but the solar telescope will, and we can align the telescope for the solar telescope and align the telescope for the main imaging telescope for star shots. That's one of my processes I've worked out. This is getting better and better here. Look at this.
I looked up this morning how far I would have to drive to get on the path of angularity. It's going to pass right over the Four Corners area.
Oh, wow.
Where Colorado, New Mexico, Arizona, and Utah come together.
Yeah, I've been there. I've stood at the Four Corners.
And that's a 7-hour drive for me. I don't think I'm going to make it.
Yeah, that's I can understand.
Now, if the total eclipse next year was that close, I would go. but you got to go all the way. Probably South Texas is the best place to be to see it, and that's too far to go. It's not within a day's drive.
Yeah,
Texas is the big state.
it is. Okay, let's see. Calabo says, just to refresh your memories, I'm about a month away from returning to work at SpaceX, yes. And he wants to offer some stuff. I know where he's going with that. I've talked to him about it. Telescopes to the subscribers of this channel to build a community of skywatchers. My hope is that this will bring more visitors to this channel and help it to grow while teaching folks how to be solid, I would say, astronomical watchers. And you hear that? That's the kind of guy Calabos is. All right. And hi, Izabela. And I'm hoping that that Calabos can do everything he says he wants to do.
Hello, Bonnie. Hello, Izabela.
Oh, I missed Bonnie.
Bonnie's
Hi, Bonnie.
here too.
Hi, Bonnie. I missed you. Sorry. Very nice. Wow. I'm telling you, this is something. Okay.
Yeah.
We're gonna come back in here and redock our stacking panel, and we've got 31 images of this. This is gorgeous. What do you think of that, Izabela? Look at that. It almost looks 3D.
Yeah. See how much better the fairy's showing up tonight too.
Look at that. Yeah.
Really pretty.
Wow. Wow. I almost don't want to leave it, you know.
Oh, this reminds me of the hood ornament of a car, like a
Yeah, right.
like an old Rolls Royce or something.
That's funny, or a Jaguar.
Yeah.
Yeah. That's cool. All right. Well, there we go. That was really cool. Pop you off. We don't need that. And now, here we are. Let's also bring back our telescope. Move that over. There we go. That really came out nice. Really came out nicely. We're only at 71% on our sensor, meaning 71% zoomed in instead of 100%. The 100 is the native size. All right, so let's go back now and check out what we can do next. It's just so much fun to hang out in this region. You know, I almost want to go down and look at the Trifid Nebula and look at the Trifid if I can, because that was, if they, oh gosh, I'm just gonna do it because this was really something. Let's make sure we're gonna be able to see it. I think we will.
Excuse me for just a second.
Okay. 1 second has elapsed. Hey, Donald Kunzer. Oh, you're right, Donald. Donald says, what you call a ferry looks like a Klingon ship. It does, actually. It reminds you of the Klingon bird of prey. Or, I'm sorry, the Klingon battle cruiser. Okay, so let's pull this up. Let's
Okay.
head west. Yeah, it truly was almost just a second. Okay, remember I talked about that blue nebula? You're going to see it now because it's around this star right up here. And this is a beautiful emission nebula with dark lanes. Hello, Cindy Murphy. You know, Cindy Murphy went to the SkyTour shop, and I think she mentioned in here she got that big blanket with the Christmas tree nebula on. Isn't that correct, Cindy? I think she did. So that's pretty cool. All right. Okay, we are doing this now. We're going to go for 35 seconds on this. And I'm going to just drop the gain to 150 on this. Just to try that out. I don't like to go below 200, but I'm going to try it. See what happens. Okay, we're searching. We're guiding. Okay, here we go. And we'll now stack. And we'll see our last one. Look at that. I don't want to clear it, but I have to. It'll be up on the server.
Cindy says she's cuddling in that blanket right now.
Oh, that's so cool. Very cool, Cindy. So you like that blanket? You like that? I imagine the answer is yes. Wow, this is nice. Look at the detail in here. This is just so unbelievable. Let me color correct. All right. That's true, Calabos. When we spoke, we talked about that. Rising Phoenix 1, how you doing? He says, years ago I would listen to the stream to meditate, lol. Now I just watch to be amazed. Well, those are kind words. Thank you, Rising. That's really kind of you. Oh, man, Calabos, you tell me when you're back to work, because I want to send you a congratulatory note. I'm going to be really happy to see you back on your feet, man. You know, some bad things often happen to good people, you know. Many of you know about my background. I mean, I had a surgery, was it 8 years ago now, Daryl? And I was ended up as a quadriplegic and blind. Imagine when I woke up and couldn't see and couldn't move, my first thought was, oh my gosh, I'll never be able to look at my telescope imagery again. That changed because I actually figured out how to fix my brain. And if they accept me for a TED Talk, I'm going to do a TED Talk on how I fix the brain. Because other people, I've actually helped other people in the country just with the process and basically. But that's not what we're here for tonight, so don't worry about that. Hey, Fantasy, what's happening? Just lurking in the back, he says. Hey, Jessica, what's going on? Look at this, Daryl. This is really pretty tonight.
Yeah, the background too. It's all very three-dimensional.
I know. I'm gonna see if we can get pull some more out of this. Okay. I'm going to do a log plot on this and pull this over, and now we'll have more resolution of our curve so we can actually play with this better. Maybe pull this back just enough to pull out the red back there. Look at all this subtle detail. Holy cow. I just can't believe what I'm looking at. Manipulate these curves a little more. Push that a little. Let's zoom out just to see what we got here. Look at all the red diffuse nebula. Those are called, that's diffuse nebula. So that's like, hydrogen is the most plentiful element in the whole universe. So when we look at the sky, you're looking at a lot of hydrogen out there. And if there's nearby stars that are ionizing that hydrogen, which is normally in the cold, dark space, you'll have hydrogen atoms, a proton and an electron. Then those electrons can ionize, leave the atom, and come back and recombine, and that recombination is what causes this subtle red glow everywhere we look. Because there's lots and lots of those hydrogen atoms. And it doesn't mean that there's hydrogen here but not here. What all this is, there's dark dust out there too that's obscuring some of these regions. And yes, there's patchiness in the clouds anyway, but this is a region where there's lots of dark dust as well. And nowhere can you see that better but when we zoom in, okay, and you see it here. I noticed that our stars are a little elongated, so we probably had some desert breezes. I noticed with the Trifid, we always seem to have that happen here. You know, I don't know.
You lowered your gain to 150 too.
Yeah, I mentioned that earlier.
Oh,
That's all right. But yeah, because I wanted to try it out, you know. That's really nice. You can see some nice detail in there. So we've done 9, and I just hit clear. You know why? Because I want to get a perfect shot. Calabos, thank you for offering all that information. You know, these are things that happen to us, you know. Yeah, see? Okay, I saw that we had a number of 3.1. I don't know why. Don't know why that happens. 0.7. We got a number of over 3.1. See 2.1 in declination there?
oh, you lost
2.3, 3.5, 3.3. So this one 5.0. So this is going to have a declination error here. You'll see right now it's going to be moving up and down. Look at that.
Wind?
Yeah, possibly. So what I'm going to do is I am going to do the following. I'm going to come back here, and I'm going to come down to the rate for my declination, and I'm going to mess with it. Right now it's 23. I'm going to set it to 24. See if that even makes a difference. It may, it may not, but we're going to find out. It's very sensitive. All right, this image won't have that in it, but the next one will. So we'll see. Fantasy says, take out the negative people in your life and your health will improve immeasurably. Yeah, well, that's true. A lot of people get very stressed over crazy people, like the people that hacked my Facebook profile a few days ago and took me completely off Facebook. Almost 5,000 friends, 10 years of photos, articles, and documents I put up there. And now my presence is no longer there, other than a blank profile. I'm still up there as Mark D'Antonio. I'm wearing a hat and sunglasses. So if you want to send me a friend request again, I'll accept it. Okay, try one more time here. And if that doesn't work, we'll move on. Yeah. Initially, the first ones were working right. So let me try going the other way. Say that. And do that. You shall see. Cosmic Ray, I'm actually doing just a straightforward stack. And I'm telling it, see raw frames here? I'm not saving any of the raw frames. But if I save the raw frames, then yes, I could stack only the good frames, sure. So why am I doing it that way? Bandwidth and storage space. I've got multiple terabytes of storage, but do you know that I'm almost a third into it? Because I'm storing just these FITS files, these data files. Okay, that looks good. Okay, let's see what we got now. Ray was asking if I save individual files that get stacked, and usually you do, and then you stack them offline. I used to do that for everybody. I would just take the raw files and then just stack them, but not online. I'm stacking dynamically right now, so all the files coming in are being stacked as we talk. That one drifted a little too. Yeah, okay. We're going to try a different object, because this is not...
Says your star lock. I mean, it never got past set decorate.
No, well, it's working in the background.
Oh.
Yeah, right. So let's try something up here. All right, I'm gonna zoom out a little. Oh, I know. One thing I haven't looked at since we got back to this. Holy cow, why am I so lax? I would really like to look at the Dumbbell Nebula now. I haven't done that since we got back into this. Since column aging, I didn't do the dumbbell, so we're going to do that now. Yeah, see how this looks? It's just not good. Let's hopefully there won't be any wind that bothers us too much. And the way the telescope points is like a big flag, you know. All right, let's come back to this. Dumbbell Nebula. Go. There it goes.
Should set up one of those little weather station rigs at the observatory.
I got a weather station.
Anemometer and all that.
Yeah. I got a weather station coming. We are going to have a weather station. There's our dumbbell. Oh, yeah. All right, so let's head west. Pull that in more. Hey, Louis Taz with us. Louis TA. What's going on, man? Michael Hedrick. How you doing, brother? All right, head east a little bit. Okay, remember I talked about the different colors. I talked about, you saw the blue on the Trifid Nebula. That wasn't that good because we couldn't save it. But I also talked about the green for the oxygen that gets ionized. And we're going to see that right here, okay, in this nebula. All right, so to see that, we're going to set this only to be a 12-second exposure, because we don't need very much with this one. It's bright. All right. And now we'll, oh yeah, see, there's that reflection nebula we talked about. So
Lewis has a question. Let me answer him real quick.
Yeah, what's he ask?
Are the welding helmets good enough to view the eclipse next week? Lewis, no, they are not.
Good answer.
The standard welder's lens is a shade number 10. And to look at the sun, you need a number 14, which was a much darker filter. So if you're going to use a welder's glass, get a number 14. You can get them at a welding supply shop. They're quite safe. Otherwise, I mean, you can get the Eclipse glasses or the Eclipse viewers that use Mylar. You make sure you're buying from a reputable source. It is absolutely unsafe to use film negatives or trying to look through floppy disks and stuff like that. You really need a good certified safe filter.
Yeah. RJP, thanks, man. I put the music together for this. And those of you that were here early, you heard the entire cut from our SkyTour radio called The Universe is Calling You by Rebecca Renfro down in Florida. And that's our SkyTour theme song. And we're going to be playing that in its entirety at the beginning of each stream as a pre-stream intro to get people to come in and wait for the stream to start. So here is the Dumbbell Nebula. Now, I got to show you something. Inside the Dumbbell, right here, you see that blue thing right there? That is a white dwarf. That's actually only the size of our planet Earth. And the Dumbbell is several thousand light years away. So imagine that a star is so bright, but only the size of the Earth, that it could glow enough to be seen thousands of light years away. Usually, the diameter of a star determines how bright it might be. That's called the intrinsic brightness, or its luminosity. These guys, okay, these white dwarfs, being only the size of the Earth, have to be really, really mega hot to be able to shine over that kind of distance and be seen that easily, like that one. And they are so hot, they give off almost all the radiation in the ultraviolet, and that's what we see here. You see this green oxygen, ionized oxygen cloud, which used to be part of the star, the envelope of the star itself that you're seeing here. This envelope has been blown off of the star, more like sloughed off in puffs. All right. So when a star reaches its final destination, so to speak, like this, a star like the sun, for instance, and slightly more massive and less massive, this is the end result for a star. It makes what we call this a planetary nebula, because it could look like a planet in a small telescope, and thus that's why they're called planetary nebulae, right? But when the star finally swells into its final red giant stage, it might do it in stages, and it might puff, get bigger, smaller, bigger, smaller. As it does that, it's going to maybe puff off its outer layers. And when it's really a big red giant, one of the things that's fascinating about this is that at the point where it's a real red giant like that, the outer layers of the star can be so far away from that core, which is now separated from the rest of the star because its stellar winds get really, really heavy duty for a period of time. It pushes that outer layer of the star off. Like, imagine the core of our sun, right? The core of our sun is a small core, right? It's not the whole sun you see in the sky. Everything you see in the sky is the big plasma ball that goes down, hundreds of thousands of miles into the sun, okay, to the core. And it's the core where fusion's taking place, not in that outer part of the sun. That's just along for the ride. And it's nuclei only. It's atoms that have had their electrons stripped. So you just have protons, free protons, and free electrons running around out there. And so that's what this guy was in its final stages. And that this stuff here, all this green, that's oxygen that was in that outside envelope of the star that has been since liberated from the star and blown off the star. And then this stuff here, this is like a little red outline. This is a really interesting jet. And there's like possibly hydrogen and neon in there. And let me just let you enjoy the view. So this nebula here, the Dumbbell Nebula, which is looking spectacular. The Dumbbell Nebula is one of many nebula that's actually something called a bipolar nebula. You notice that it seems like it's going this way and this way, okay, and that there's less going this way. So it's possible this was a rapidly rotating star, and that maybe this is the equatorial region here of the star, and when it was rotating, it sloughed stuff off this way and that way, and less at the poles. Now, I have to look and see if that's what happened with this particular one, because I'm hoping that I got that right. I haven't looked at any of the papers on this today. I've got to do that. All right, let's...
I wonder, almost looking at it, if those aren't like polar jets.
I know, that's why I was just saying that.
They're precessing.
Yeah. Yeah, precessing means doing this. Okay? Just like our Earth does. Earth precesses every 26,000 years on its polar axis, so the North Pole star seems to drift. That's because the way direction the Earth is pointing, changes every 26,000 years, and that is called precession. And stars can possibly do that as well. And if they do that, then when they're sloughing off their outer layers, you might get this pattern like this. So we have to look, but it's a bipolar nebula. You can see it's like an hourglass feature. And if we were to show it even better, all we have to do is pull this dotted line in to start removing our background more and more and more, and you'll see that what's left is this bipolar shape. All right.
Today's APOD has a picture of the hourglass nebula, they call it, I think.
Yeah.
I forget its designation offhand, but it is a very, very detailed image of a planetary nebula. And the precession going on to form the hourglass is obvious when you look at the image.
Okay.
It's quite a picture.
Cool. This is beautiful. I'm going to rename this. See what I'm talking about? The wind in certain locations, certain directions. It's just not a problem. In others, it's an issue. We probably were facing wind coming in and hitting that barrel and torquing the barrel up or down a little bit. And when it's like this, it can withstand it because we don't have any problems with guiding right now. In fact, it looks stunning. So I'm going to save these images here and then save exactly as seen. That's probably the finest dumbbell we've ever taken right there.
Now, can we zoom in a little bit on it?
Yeah.
Curious about the little cloudy details, especially there at the top left quarter.
Up here.
Yeah, all that, and then the greener clouds a little farther in.
Okay, like in here.
Yes.
Yeah, you can see a lot of detail and modeling in there. Really fascinating.
Good picture.
Yeah, let's turn off the enhancement. Okay. Turn it back on. Okay, it definitely. So that you notice the color of this white dwarf, by the way. This star in the center. Notice it's blue. As I told you, the white dwarfs are exceedingly hot. They're no longer undergoing fusion, but this is the heat left over in the core of a star that used to be many tens of millions of degrees. And so when you're talking about something like that, it's going to be very, very hot. And the hotter stuff in the universe is more blue. So when we look at this, it's blue. Ta-da! Gorgeous.
Lewis asked a few minutes ago, what was the size of the star that formed the white dwarf? I gave him a short answer in chat. You could probably expound upon it if you wanted to.
Okay, I didn't get to see your answer, but I can say this much. Depending on what the star has for spectrum in here, okay, we know there's oxygen in here. We know there's hydrogen. We know there's probably some neon, maybe other elements. By looking at the actual spectrum of the Dumbbell Nebula, we can make a determination as to what might have been in the original star. And because it's a planetary nebula, we know that there's a lower limit of the mass, or an upper limit of the mass, for it to be a planetary nebula like this. Beyond a certain mass, we'd see a supernova, and we'd see either a neutron star or a black hole. A neutron star, either a magnetar or a pulsar, or just a straight neutron star, or a black hole. So we know the upper limit on the mass of the star for sure. What kind of star exactly? Not sure. But definitely it's going to be the mass of a star kind of like the sun, maybe a tiny bit more. But not much more than that, because then you go into the neutron star world.
And that is the Chandrasekhar limit I mentioned.
1.44 solar masses. But that's 1.44 solar masses of the core. The core, this core remaining thing has to be 1.44 solar masses, which would imply that the whole star might have been, say, 2 or 3 solar masses, or 4 solar masses maybe, and then the 1.44 solar masses is what's left over after all this stuff is blown off. And so that's where the rub lies. So certainly this core is less than 1.44 solar masses, which is the Chandrasekhar limit that you were mentioning. Yep. Yeah, you can see more green stuff out here.
Yeah. A lot of red stars in the field, too.
Yeah. We are heading towards Cygnus, so we might be seeing some dust causing some extinction here, or we are looking at M stars. Okay. Save it again. Save exactly as seen. Alright, guys, say goodbye to the Dumbbell Nebula for now. Bye. We'll see you again. Alright. And now we'll head to night vision mode. Okay. So now, let's check something else out that's really pretty at this time of the year. And we're trying to do this before the moon rises. So what time is moonrise tonight, do you know?
9:07.
9:07. All right. We're at 8:46 out there. Okay. So we're going to keep moving up here. Yeah, maybe, huh? Let's go there. Going to a feature of the Veil Nebula known as Fleming's Triangle.
Or Pickering's Triangle.
Yeah.
Mark, excuse me just a moment, please.
Sure.
Right back.
So this is a supernova remnant. This exploded, oh gosh, I forget how long ago. I think it was only like 8,000 years ago. But let's just do a photo that's 35 seconds long on this. We're guiding now. And let's hopefully we won't have any problem with the wind. We're looking straight up, so the resolution of this is going to be the best we will get for the evening. So let's check it out. We'll live stack and get rid of the last image. There's the Dumbbell Nebula. Look at that. Really pretty. So we'll clear that. It's up on the server by now. Cosmic Ray says, the lure of Cygnus just too strong. Well, actually, you're right. It is, and oh, look at that. Let me, what did I miss? I think I probably should have, okay, well, we got a little bit. This is where we're supposed to be. Okay, let's clear this and come back. We'll just move ourselves back over. Cygnus has got an awful lot of really interesting detail in it, so it's really hard to just walk away from Cygnus. Alright. We can increase the gain in order to see some more details in here while we do this. So there is the eastern veil. So we're going to go down. Okay. And then we're going to go west. Okay. Take a quick 20-second shot. And we're at 250 gain, so it's pretty high. We're going to come back down to 200 for that next shot. I'm not stacking this, I'm just trying to get a... Okay, that's where I want to go, right there. This is a beautiful area, and we're gonna check that out. That's the central veil, and it's just stunning. So there it is. So we're gonna head to the west a little bit. You're gonna see the most amazing filamentary structure in this region, actually. A little more to this way. Thanks, Ray, for putting that up. All right, let's see here. A little more this way. Okay, so hidden undercover here is a beautiful area, and I think we got to go down just a little more. There we are. Okay, now we're going to let our guide star come in, and we're going to take a 35-second shot here. Again, our telescope is pointing straight up, so we are doing well. Our guiding is now stable. So here we go. And let's jump in more and bring up our stack. And we'll clear this. And we'll name this the Central Veil. And what you're going to look here at and see is the most amazing red and green colors, and this is from the fact that we're looking at oxygen, okay, in the green, and we're looking at hydrogen in the red. Okay, look at that. That is just stunning. Let's color correct. Okay, so this is one frame. As we stack our second, any noise you see, I'm at 250, I want to drop down, so let me just clear this and drop down to 150. Actually, let's do that. All right, and this next one will come in. It might look weird. Okay, let's just see what it looks like. Yeah, okay, we'll clear that and we'll wait for the next one. So now we're going to see a beautiful green oxygen, ionized oxygen filaments with hydrogen filaments. And the processes going on out here are pretty amazing. There's some thoughts to indicate that maybe we're looking at electric currents running through this nebula region and causing these to twist and turn in so many odd ways. That is something that has been a very recent thought. Not sure if it's true, but it actually is something that could be going on right now. That's amazing. And let's do this, and then do this. Come up on our black level here, right to just before the end of the curve. And that'll be as dark as we can get the background without losing data. Hello, C&D boy, how's it going? Okay, so as we stack more, you'll see it gets clearer and clearer and clearer. Gosh. Absolutely adore this new camera. It's really performing well. Thank you for putting up the OneDrive link, Daryl.
Sure.
Look at over here. Okay. This region right here, there's a marked area here that's quite bright. Now, why would that be bright? It would be bright because there must be material here that's either being snowplowed by the outward force of this supernova. Remember, there's nothing to stop this except the interstellar medium itself. And so the materials that are being pushed outward from where the supernova went off to cause everything you see here, this was the guts of a star. A planetary nebula we saw, relatively quiescent, kind of confined. A supernova blasts its guts to space. And so that's what we see here. And in many cases, shockwaves form along the fronts where these things are moving out. And so things like this might be the result of a shock front. Okay, like up here. This could be the result of a shock front right here, causing this. See, it's stuff like this you just never get to see, right?
It's actually quite a bit of detail inside all that.
Yeah, right? Look at
The whole
that.
thing's kind of an S shape.
Yeah, look at it. Look at the detail up here. You've got more than one filament up here, you know? And we've only stacked 5 of these, and so we're getting more and more detail. Look at that. That is absolutely stunning. So the green is the oxygen and the red is the hydrogen. And there's other things in here other than hydrogen and oxygen. Stars are made up of lots more. And this star undoubtedly had all kinds of other elements: calcium, magnesium, phosphorus. You name it, it was in there. Okay. So it probably pumped that out. But this is the dominant spectrum that we see of the oxygen. This is actually doubly ionized oxygen. So 2 electrons on the oxygen atom blew off. Okay. So that's that. And then in the red one, of course, as we mentioned, the electron was powered off the atom by absorbing energy. And then when it went back in, a process called recombination, it cascaded down a few levels. And they stop at different levels and give off different light. But the predominant transition, as they're called, is the one to the second level in the atom, n equals 2. N is in November, and the n equals 2 level. And when it comes in from the outside like that, it drops to that level, it glows red. And that's the predominant color we see. And what looks like this elegant gossamer filamentary structure was born in violence, a cataclysmic explosion. Look at that. Now you see why I like this camera so much. Look at these ribbons.
Yeah,
in
I've
here.
never seen that lower part before.
Yeah, right? Look at the ribbons in here of just very complex material. This is why they thought maybe there's electricity out there running, electric current that's been generated by the materials moving against each other, kind of like we have an outer core and an inner core of the planet Earth. Rubbing differentially against that inner core causes massive electric currents, which result in magnetic fields. Therefore, maybe this is being shaped in part. Maybe these gossamer strands like this are being shaped in part because of magnetic fields and electric charges. Because if it's ionized, keep in mind, an atom in there, what's called the ground state, it has all the protons and all the electrons. And what's the charge on that atom at that point? 0. It's a net charge of 0 because it has as many negative electrons as positive protons. But when you ionize an atom, then the electrons get driven off. And now you have negative charges running around and you have positive charges running around. Electric charge. So that could have a great deal to do with the shape of this nebula. So that's how that could possibly work. I say could possibly because we don't really know yet. It's sort of an infant technology right now. Look at this beautiful element right here. Holy cow. We're not even halfway magnified. We can go up to 100%. And look at that.
Yeah.
Wow. I'm saving this now. You know why? Because in case we get a big wind, a freak wind, I don't want to lose this. Okay, we got it. When all else fails, we're going to have this beautiful thing. In fact, I'm going to do before what I did. I'm going to get rid of this. Okay. And I'm going to take down our stack. We're still stacking in the background. But this way you guys can see the whole thing. Wow, let's back out for just a minute. I heard someone say, I can't tell you who because I couldn't hear it. Back out, let's see the whole thing. And this guy is our next target. This is called the Witch's Broom, and it's to the west. Okay, so east is that way, west is that way, north that way, of course, and south that way. Look at that. This is amazing. So much detail. Wow.
I kind of see a dragon's head in the triangle.
Up here? Or is it this?
Yeah.
The eyes?
No, the
Sorry, I just yawned. Holy cow.
a couple actually.
That looks
That
like
red area there, it's kind of like an upside down pear shape. Farther down.
Oh, right here, you mean?
Yes, that, and then the whole triangle running about down to the center of the screen or more.
Oh, yeah, you're right. Here's the eye.
Could be,
Here's the
whole
ears.
Dragon's head and the tip of his nose at the bottom.
Yeah, here's the ears or the leaning back. Here's one eye. Here's the bridge of the nose. This is the nose, and he's doing something with green stuff. That's interesting. And yes, before anyone says it, we know that's pareidolia, of course. Calibos talks about Betelgeuse. You know, Betelgeuse could have already exploded, and we won't know about it. If it happened yesterday, we won't know about it for between 550 and 750 years, depending on what the actual distance of Betelgeuse is. That's always hotly debated. Hey, Gladys. Gladys 1 is here.
Sam says a sneezing dragon.
Yeah, exactly. Wow, this is nice. Okay, this is 16 stacked images. But look at how pretty this is. And what we'll do, I'm going to zoom in here. Okay.
There's a lot going on there, too.
Oh, man, this is 100%. That's 100% in the sensor. And all this modeling in here, that's noise that we can actually get rid of. And our stars are slightly elongated, so we do have a tiny bit of problems out there with the wind, but we're good. Look at this. I mean, where do you see this? This is live in real time, right? Live in real time. There's just no one doing this. And I don't understand why. It just seems like such a thing to do. I guess I make it seem easier than it is, and I'm kind of buying into my own hype that it's easier than it really is. 'Cause I know
lots of paint stuff in there too.
Oh yeah, down here.
Between the main triangle and the blob on the right, there's all sorts of faint green and faint red shot
Right
through
here.
through space there, and then farther down right there.
Yeah, like down here too. Wow. Okay, this is 18 stacked. We'll go to 20. Then what we're going to do is we're going to go down and we're going to image this. Look at the detail in this already. Look at this. We've never seen detail in the witch's broom like this before. This has been completely out of reach. Look at that little filament right there.
Yeah, I think you're gonna. You already said you're going to, but I think you need to go there next.
Yeah. I'll do it in a way that we can overlap and do a mosaic of this and the next.
Okay.
I'm gonna go straight down, and that should allow us to put this together without any kind of black blobs in the middle. Because to the right of this, there's not much else out there, and this is kind of heading down in a direction like that. Okay, so we're at 20 right now. So what we're going to do is we're going to save this just like this under central veil. Save exactly as seen. Okay, now what we're going to do is we're going to redock this for the moment. And we're going to get out of here. I've got to bring back the telescope here just to allow me to see what's going on. And we'll go back to our night vision mode just for a split second here. And now we're going to bring these stars up here. Okay, and that should bring everything up. And we'll see 52 Cygni show up in here as well. I think that's 52. I gotta take a quick shot to make sure. 10 seconds is all we need for that. Okay. And I won't be stacking it, just a placeholder just to make sure.
Darn, I got half of mine to go put some big boy pants on. It's getting cold.
Really?
Yeah, I'm still wearing shorts.
Oh. Alright, let's go back to this. There it is. Okay. So let's go back down a little more. Look at that dragon sneeze is continuing down here. Yeah. And let's just bring that up. This is going to go out of shot above by a little bit. Look at that. It's like the Matrix.
Yeah.
Okay. Oh, this is going to be just a little bit close. Okay, that's where we want to be right there. Okay. Alright. So that's a 10-second shot right there. What we're going to do is we're going to make that again a 35-second photo.
You're zoomed in somewhat.
Yeah, actually not really. Notice the bottom here. Okay. If I show you where that is, I'll show you in a second. 35 seconds. Alright, like that. And if I show the zoom level, okay, see what I mean? We're actually it's right at the edge. But I want it there because I don't want to have any black blocky missing areas. Okay. So let's bring this up and check it out one more time. Oh my gosh. So there is the thing we're checking a picture of, and it's going to be down here now. All right. So we clear that. And this is now going to be Witch's Broom, or Western Vale. Look at that. That's going to be really pretty. You can see all that detail to the left. Wow. I'm not even getting it, am I? Here we go. Alright, Western Vale. That's literally right at the extreme edge. But we want to capture all this. And this will start the foundation of a further mosaic that we'll do and continue.
Izabela went to bed. She's tired.
Okay.
Maybe she can paste it together tomorrow. Or you could even.
No, I'm gonna. I will be
I'll just
pasting this
spectate.
together. Yeah, I'll paste it. Okay, let's do this. Okay, so I'm just really impressed with how really pretty this looks. So we come up, okay, see that? There's the star that was in that past image. So we have this here and down that will link perfectly to this stuff from the central veil, which is here. This is something else. Oh, look at these really subtle loops down here. Look at this. Wow. Let's color correct that because our background's a little bit blue. Look at that. Look at these gossamer loops here. Again, this is why the thought that maybe there's some electrical charge at work here and charged particles that are in part shaping some of this are in play, because the spindle, okay, like this. Look at these shapes. These shapes are extremely complex. This one here, by the way, this star 52 Cygni has nothing at all to do with the supernova remnant. It's not illuminating. It's not part of it. It's a foreground object. This is farther away. Okay, this is really something. Let me zoom out now. Okay.
RJP asks what the Bortle rating of the sky there is
What?
in Arizona.
I'm sorry, what? The Bortle?
RJP asks what is the scope sitting under
Oh,
Bortle wise? What
a
scale?
2.5. 2.5. We had to be near enough civilization in order to get any help we might need, because getting someone to go miles out into the desert is tricky enough. Now, we're going from Bortle 2.5 at this location to Bortle 2 a little bit west for the next telescope. Now, what's the Bortle? John Bortle was a guy that measured the brightness of the sky. Bortle 9 is downtown Phoenix, for instance. Bortle of 0 is in the middle of the Pacific Ocean, far away from any potential light sources. Right. So anywhere in between are on places like the Arizona deserts. Bortle 2, 2.5. Now, where we're located exactly, there is some controversy. I saw Bortle 3 listed at one point, and if you stand under the sky and you look down, you can see your shadow by the Milky Way when it's brightest, okay? And it's a fuzzy, diffuse, darkening. So that's something you just don't see, okay, in a Bortle 4 sky beyond. And you can see the zodiacal light easily with the naked eye. Zodiacal light is the backlit particles in our solar system that coincidentally might actually have come from Mars. That's a whole nother line of thinking. And so it really looks pretty there. When I was out there a couple weeks ago, I flew all the way out there just to collimate the scope for an hour. Look at the beautiful sky now. Look at the stars. They're perfect. And they're perfect because I was able to fix the alignment between the lens and the main primary mirror. It was cocked a little bit. And as much as Marianne and Tara tried to fix it, they don't know how to collimate a scope. And that's something you don't teach someone over the phone. You got to do that right there. So I flew out there courtesy of the SkyTour live stream, and I collimated the scope. It took me a full hour out in the desert after the sun went down, obviously, because you got to collimate on stars. And luckily, I was able to do that. And as I walked in the door, the door has that beautiful nebula on the front of it, done all in colored bottle caps by Tara, who is our artist actually. And as the door was there, right below the door is the bottom edge of the building, and then it goes down about 4 inches to the desert dirt. Well, under the door and down to the dirt was a spider web, and I just kept walking over it, in and out, in and out, in and out. And then finally I noticed a spider was in it, and the spider was about the size, a little bigger than a quarter and a little less size than a $50. And I realized, I got down close and I started looking at it. I realized, wow, this is my first black widow. I've never seen a black widow, but there she was with that beautiful red hourglass on her belly. So it was the first one. So that was great. And it was just a few months ago that when they were out there reinstalling the telescope after having to have it serviced, the observatory had a tarantula the size of my hand sitting under the computer. And one of the 3 people in there panicked and screamed and ran out. And it just happened to be Marianne, who was on the phone with me at the time, and she ran out screaming, which I thought was hilarious. And tarantulas aren't going to hurt you, and neither are black widows. Actually, they never leave the web, so that's why I kept stepping over it. Once I realized that it's in the web, it's not going to come crawling after you. They're in their web. That's their house. They don't ever leave it. Tarantulas, on the other hand, they roam around, but they're harmless. They don't bite. In fact, that's why people get them as pets. They put them on their shoulders. They go to the store, and people freak out. But you have a dog, and the likelihood of a dog biting you is always there. But if you know your doggy, you'll snuggle right up to him, and you don't care. Well, tarantulas are the same way. They're not as snuggly as a dog, but they are. It is similar, for people that like those arachnids.
I mentioned before the annual tarantula migration is happening here in Colorado right now.
That's
Eastern Colorado.
The mating drive of the male tarantula.
Yep, thousands of them crawling across the landscape.
It's happening in New Mexico too. It's happening in New Mexico too. I was talking to someone, and they said that there was a tarantula on the stairs of their hotel, and they called security, and it's like, well, what did security do? Did they kill it, or just gently move it? Because to move the tarantula in our observatory, the husband of Tara walked over and just put his hand down and coaxed it to go up on his hand, and it was on his forearm, and he just walked outside with it and kind of gently coaxed it off his arm back into the desert. So it's not like they're not sitting there waiting to bite someone. They're just they're just doing their thing, and they're actually very docile. Actually, creatures that aren't docile are things like scorpions. There's scorpions out there, but again, they'll bite you just like bees will sting you, you know, and that's about what it feels like, you know. Look at this. Holy cow.
Scorpions don't bite, they sting.
Well, I know, that's what I mean. This is really pretty. See, when we take pictures, we always take pictures of like this over here, this here, and it's always central. And we miss this stuff. Look at this subtle stuff coming down. We're going to be able to bring that out in a final image. And man alive, for the folks that join our Patreon, we make these final highly processed images available to you. But the raw images, like you see here on the screen right now, these are available to you just by going here, skytourlive.org. And you'll be able to see it. Okay, this is Western Vale. We're going to save it now. And save it exactly as seen. And that's good.
I used to have a lilac bush in front of my house, right in the front of the front wall of the house, by the sidewalk.
Yeah.
Front wall. And every year, just a little bit earlier than now, late summer, an orb weaver spider would show up, and it would build a great big spider web between the lilac bush and the eave of the roof. And year after year, I don't know if it was always the same one or, you know, succeeding generations, but every year, an orb weaver would show up at that same place late every summer.
Yeah.
Beautiful spider. And somebody said, Chad, I mean, it
Golden
was a
garden
big
spider
too, but you know, I just left it alone because it was doing its spider thing, gathering food before winter came.
Was it a golden garden spider?
It's been a while since I took the bush down. Okay. It was kind of yellow and black.
Yeah, sounds
Pretty
like a
big,
golden garden spider. Yeah.
Yeah.
About that. The body's probably the size of a quarter, maybe a little bigger, and then the legs came out. You know, maybe an inch and a half, maybe 2 inches.
Yeah, it wasn't huge, but it was a fairly big spider.
Yeah. Yeah. RJPX.
Cool.
Yeah,
Cool to watch
I don't.
him.
It is RJP. Yeah, I don't kill anything either. I actually, you know, my mother. We talked about this before. My mother was in part Native American, so I've always been kind of tuned to the world and to the earth. And maybe that explains why animals would just come up to me. I was in my shop working. I've told the story before, and a skunk walked right in. And I just kept working on my project I was working on for the Navy. And it came over and it sat down right next to me. And I ended up squatting down and actually scratching it on its back, and it rolled on its side. And I had a friend for life. It followed me around everywhere I went. And every morning I would open the garage door and he'd run in and say hi to me. And he'd stick around all day. And he smelled like a skunk. So I was like, oh, well, you know what? He doesn't know he smells, so I can't fault him for it. So it's pretty cool.
As long as he didn't make you smell like a skunk.
No, he didn't. He never sprayed me once. You know, he lives under my shed now. He's still here. Then I had the blue jay that landed on my shoulder every time I went outside, and I would take him off, pet him, and give him seed after a while. And every time I go outside, I call JJ, and he come running for flying. Then there's the fox. Fox tried to get in the house one day, and he saw me through the screen, and I didn't let him in, but I actually did set up a have-a-heart trap outside. And he just walked in before there was any bait. I was going to get bait because he had mange, and I wanted to help the poor thing because he had mange. And the lady across the street was a wildlife rehab specialist. So I said, oh, I'll catch this and bring it over to Veronica. And as I was walking in to get the bait, I heard the trap click and ka-chunk. And I looked back, and he was in it already. And he wasn't struggling. He was just sitting there. So I was like, Foxy. So I brought him in the house. I made a box with a blanket in it, and I opened the trap and let him go into the box. He just sat there. And, you know, I was scratching his head, and he smelled terrible because of the mange, you know. But he was really enjoying it. This mange was really bothering him. So I fed him Hamburg, and before the end of the night, I was actually feeding it by hand, you know. And he was very, very gentle and very docile. So the next morning, I brought him over to Veronica, and by the time I came down in the morning, I thought maybe he'd be out all over the place, poop everywhere. Nope, he was in the box. When he saw me, he just looked at me, and he knew maybe that I was trying to help, perhaps, who knows. And the result is, I brought him to Veronica. She nursed him back to health, and she let the fox go right near my house because that was his foraging path. That's where he was used to. And he came back, and he started sounding like he was crying like a little baby, like a baby, because foxes can go all that, make that noise like they're kids. They make the sound that gets mistaken for babies. And I went outside thinking there was a child out there, and it was Foxy in the driveway, and he saw me spinning around. He looked beautiful. He had this beautiful bushy tail back. The mange was gone. And it was just so nice to see. And for the next couple years, he would go through our security cameras every single night at 2 a.m. because that was his foraging path, foraging route. Every night at 2 a.m. This is gorgeous. All right, we're going to save this now. Wow. Save exactly a scene. And let's zoom in on a couple of items here. Look at this nebula section right here. This is really stunning.
That's the tail end of the whole Pickering's triangle thing, isn't it?
Yeah. That's basically the sneezing dragon. This is the sneeze. But see that? Something's causing that to get brighter. Now, yes, density can. But why density? Maybe this material spreading out from the supernova is striking dark material or more material in the interstellar medium that's causing it to snowplow and compress. That'll heat it up and cause it to ionize as well. But we see some of these things better because these are denser strands. Like this is not very dense right here. Okay, but this is very dense, and you can see the strand very well. But the whole question becomes, why are they strands? And that's where this other theory came up I was telling you about. Okay, so we just did that guy, and I think that's good. So the next thing we should do, let's come back here. Right. So we are right here now, basically. And our eastern veil. And the central veil comes down here. There's that strand I was telling you about right there. And we'll see all that. And we photographed this just now. Then we drop down. Now, if I go over, we're only going to catch the bottom of this. But we can do that another night. So what I'll do is try to bring us to something a little bit more interesting than that. Although it is pretty. Excuse me. Okay, so... Okay. Water. Thank you, Bonnie. Truth is stranger than fiction. I have witnesses, too. Especially a neighbor who saw the skunk walk in my shop one day because he was coming in to spend the day with me because I was working there. I had the garage door open. And he called the police. And they called animal control. And animal control had to come and remove the skunk, they said. And I wouldn't let them take it because I said, it's my skunk. You can't have him. So, animal control did not get the skunk. But then again, I shoot him down the embankment to keep them from getting him. And then he vanished for like 6 months. So I was really mad that he was gone. But then he showed up again with his whole family. Okay, 4 babies and the mother skunk. And the mother was not happy that Skunky was coming over and hanging out with me. She was probably saying, don't get any of that on you. Does that stuff even wash off? The mother skunk was probably saying. Okay.
Sorry, skunks carry rabies here. I try to keep my distance.
Yeah, they're known to carry rabies. Bats have been known to carry rabies. You know, lots of creatures carry rabies. All right. Ooh, I wonder. Should we do the tulip? No. Let's actually come up here. Keep going. We did. Let's see if it's up high enough. The elephant trunk we did.
Well, that's right.
Yeah. Came out beautiful. Ooh, let's do the wizard.
Sure.
The wizard we haven't done. Yeah.
The moon is up now in Arizona, by the way.
Yeah, I know. We're going to do this object, and we'll have to correct for the blue color, and it'll be slightly more red. But that's all right. Okay. Let's go up a little higher. Must be here. I'm guessing it's there. So we're gonna go and head to the west a little bit. Let's see if I'm right. I think it's right here. A little more. Okay. And we'll set this up for just a quick 10-second shot just to get our place. Make sure this is the wizard. I believe it is. Then we'll drop our gain back down. That's the wizard. Okay. Okay, so we'll drop this. Drop our gain down to 150. Set our time to 35 seconds. And off we go. So last thing we did was this image here, the beautiful beautiful western veil right here, many light years long. You've always said that this area always reminds you of like a tornadic action, like a tornado.
Yes.
All right.
Like, very much like a vortex spinning.
Yeah. There is the Wizard Nebula right there. That's looking good. All right. Let's get that to give us a little bit more. Here we are. Color correct. There we are. Now this this is going to show us more detail than we've ever seen in it, really. So this is going to be interesting to see how this comes out.
Curtis Horn is here.
Hey, Curtis. Good to see you.
He suggests looking at NGC 7822.
Yeah, that's one that we have to do yet. Curtis, this is our last object for tonight. Sorry, but you know what? That's an excellent idea. We'll do 7822 for sure. We are definitely going to do that one. Here is the Wizard Nebula. And we're seeing way more detail with this new camera. This new camera, Curtis, it allows us to see just in a huge amount. Yeah, that's you're right. The camera's the 183, the scope's f2, correct. Aperture's 10 inches. Oh, Gladys, I'm sorry. What I did, Curtis, was I tried to optimize the camera for the setup to get the most arc seconds per pixel and not oversample or undersample. And this gives what is a good to very good result. And that's actually why I did it this way. And when you're calculating that, you get to use our wonderful number 206265. There's your wizard, Daryl.
Oh, yeah. Let the image build up some. I don't see the girl yet.
Oh, let me help you out.
I see his right hand. I see his left hand. And it's like his arms open to her.
And here's
She's
her.
a little girl on the right there, yeah. Can't make her out very well yet, but that's her.
Mm-hmm.
And she's sort of like reaching her arm back out to him.
Right there, yep.
Yeah.
Yeah, this is nice. Objects we have to look forward to are the Iris Nebula, NGC 7822, as Curtis suggested, and a variety of other NGC objects. There's some galaxies out here that we'll want to see. More than just Messier 31 and Messier 33, the Andromeda Galaxy and the Triangulum Galaxy, respectively.
Yep. And Taurus is coming up.
And we have the Crab
soon,
Nebula,
if
which
not
I can't
already.
wait.
Huh?
I can't wait to see the Crab Nebula with this.
Yeah.
This new camera is going to show the filamentary structure in the Crab Nebula just amazingly well, I'm sure.
Got the Crab, got the Pleiades, got the California Nebula.
Yeah.
Up where Taurus and Perseus are close together.
And now the Pleiades are going to be... we're not going to be able to encompass the Pleiades entirely in the field of view. I think one of the stars is going to be out. Probably, is it Atlas at the end? Or no, Pleione.
I never can keep them all straight.
Yeah, and
Atlas,
one.
Pleione, Tegeta.
Yeah. Wow, this is something. This is building up nicely.
I can kind of make out the girl now.
Let's see what else is in here. There she is.
There she is.
Yeah.
Yep. You can see the wizard's face, and I guess that bright star is his eye.
Yes, sir?
Yeah. and his hat's on top, and the red thing on the left is his right arm,
All
and
right,
the
here.
thing on the right side is his left arm. He's got his arms open toward the little girl at the lower right, and
This is the little
she's looking
girl's
up
head.
toward him and reaching her arm out back toward him.
This is her little head. This is her body, and this is her left arm.
Yeah.
Ain't pareidolia wonderful? Wow. Okay.
Cool picture, too.
Yeah. So let's just drop this down just a bit to try and take out a little more of the noise. And back up a bit to try and pull out some more of the detail. Now we do have a moon up right now, as we said, but it's actually waning. It's waning gibbous now. So it's not as bright, but it is up. Okay. Really nice. So, magic trick. Poof. There you go, a name. Okay. Yeah, you reach a certain threshold, guys, with the images where all of a sudden they start to really form. And we've just reached that stage. You'll notice here that now the details are starting to really show up and shine well. And that's pretty interesting. Now we could increase our sharpening a little bit and to get a little more detail. So like that. So that looks pretty good. Now you can start to see some detail in this section of the nebula, which would be called his left or right arm.
Yeah, that's his right hand right there.
His right hand, yeah.
Yeah.
Yep. So you can see also a very interesting pillowy nebula here. Something that was lost to us with the other camera. And that's beautiful. That's showing up very nicely. There's a lot of dark nebula out here, and this is a little pocket of hot star ultraviolet energy that's causing this hydrogen to glow amid in a region where there's a lot of dark nebula here. This is all dark nebula in here. Dark dust. And if not for these stars right here, this would not glow. So let's zoom in now. Wow, look at that. Now we're seeing more detail in her, very much so.
Yeah. Can you brighten it just a shade?
Yep, sure can. I can brighten it a lot of shades, actually. How's that?
Yeah, that's just enough to bring her out a little bit more.
Yeah.
Trisha says she doesn't see the wizard.
Oh, we'll help you with that.
There you go. I mean, he's wearing a robe and he's got the big bell sleeves. And
here's the hat.
Yeah, there's the hat and there's the face.
Call this the head. This is a shoulder. The right arm coming out here with his hand. Or actually, the hand can be down here, actually, too. But that's like the shoulder with the right arm. And then this is the left arm reaching out in darkness with the left hand. This is the body. And he's wearing that robe, like Daryl was saying. This isn't obviously real. This is just what it looks like. And then here's the little girl. There's her head. There's her arms sort of reaching out. And here's her body. And the wizard is much, much bigger than the little girl in this image. Now,
Yeah.
obviously, again, it's just fanciful. It's just a fanciful way of looking at this. Again, we've never seen the wizard with this much detail. This is really quite nice.
Yeah.
Very like this. I like this very, very much.
That's cool.
Mm-hmm. Yeah. So we've got 18 stacked here. We'll go to 20. So if you guys have any idea what you'd like to see, and you know the sky a little bit, like Curtis Horn suggested, NGC 7822, then by all means, please let us know, and we'll be happy to check those out for you. By the way, Tricia Ferreira, hello. I didn't forget about you. I just didn't get a chance to get a word in edgewise over myself. But it's nice to see you. Thanks for coming. Make sure you guys subscribe, and if you want, become one of our patrons. We love our patrons. They supply us with support each month to allow us to continue doing what we're doing. And we have $3, $5, patron limits. You can just join for that, So, join our Patreon. We definitely use you.
And hit that like button, please.
Yeah, do that to help us with the algorithm. All right, we're at 20 now, so we're going to save the wizard at 20. Just so pretty. Wizard showing, and by the way, guys, check out here. Remember what I talked about with the red diffuse nebula, right? If you notice here, there's like a haze here, that's sort of bluish. Well, there's actually some reflection nebula in here. Nebula that are the result of just the star's light being scattered by the dust in this region, and we're seeing a little bit of it here. It's pretty much overwhelmed by a lot of the hydrogen, but you can see it. We'll see that in earnest with the Pleiades, because they're going to have a lot of blue dust around them. All right, let's just do one more color correction. There we go. And now let's zoom out to show you the whole picture. That's the Wizard Nebula. And we'll wait for one more exposure and then save it again.
Tricia, I could be wrong, but I think you have to use a credit card.
For what?
Patreon.
Oh, well, people use PayPal and so forth, yeah. There we go. So there you go, guys. That is really something. And for those that arrived early, you got to hear the full universe is Calling You song. It's a song written by Rebecca Renfro in Florida. And it's our theme song for SkyTour Livestream. And at the beginning of every stream, it's the pre-stream song you hear while I'm getting things set up and ready to go. And it's really, really pretty, and talks about the universe, of course. And we're going to be updating. It's a video, and we're going to be updating that with newer imagery as well. So it's really cool. Anyway, thank you guys for coming in. I'm sure that Daryl and I would love to see you again. So do make sure that you click that bell and select all notifications, and do hit the like button if you would, and let us know what you're thinking. Leave comments in the comments. We'd love to hear from you. I just think that it's a real good time. There's nobody doing what we do, to be honest. And I don't know why, but no one brings you the universe live in real time. You know. So I'm an astronomer. It's what I do, and this is all I do. So, well, not all I do. I mean, I do have another company that I run that does model making for the Navy, but that's different. It comes and goes. Sometimes I have work, sometimes I don't. But I look forward to seeing you guys again, and I'm sure you do too, Daryl, right?
Oh, yeah, sure.
Yeah.
Good night,
All
everybody.
right, guys. Good night, and you guys have a good evening, and we'll leave you with our outgoing video. So we'll talk to you another time, actually, and that won't be too long because I like to take advantage of the dark moon. Okay, so long, everybody.
Good night.
Good night, everybody.